No.
Okay, we're going to start lesson 7.5 just by reviewing the primary trigonometric ratios that you just used on your quiz. They are sine of angle theta. They are the cosine of angle theta. And the third is the tangent of angle theta. And each of these is a primary trigonometric ratio. So they are a ratio. That means they're going to equal a comparison between two numbers. Sine ratio is equal to the ratio between opposite over hypotenuse. Cosine ratio of a given angle is equal to the adjacent over the hypotenuse. And the tangent of any angle theta in a right angle triangle is equal to the opposite over adjacent. One little note, this only applies to right angled triangles. So what we're going to have today is some right angle triangles. Some of our diagrams will have two triangles in them. We'll have to use information from one to solve the next. And some of them will be word problems where we'll have to figure out what the triangle looks like in order to solve the problem. The first thing we need to learn is a couple definitions. Angles of elevation and depression. Angles of elevation and of depression. So in your little box there, the first term that you're going to have in your top left box is angle of depression. Now what does the word depression usually mean? You know any synonyms of the word depression? Okay, so emotionally you can be depressed or you can be stressed. Is that an up feeling or a down feeling?
Down.
It's a down feeling, okay. So the angle
like
of depression is the angle measured below the horizontal. So that's not your next box, but what is it? Is the third box. It's the angle measured below the horizontal. We'll explain what horizontal is in just a moment. So if we were going to draw a diagram for the angle of depression, we're going to start with, on the right side of your box, draw just a vertical, like a wall. This is under picture. And then we're going to draw this dotted line going straight across. It's perpendicular to the wall, to the vertical line, and that is called the horizontal. Okay? So if you want to give yourself a little bit of a cue, you can draw an arrow from that. Draw it from above because the rest of our diagram is going to have things below. But the horizontal is right there, that dotted line. Now, we're going to draw another line that meets the bottom of our building, the bottom of our vertical line, with another perfect line. So we've kind of made a bit of a triangle here. We have a horizontal, we have a vertical, and we've created an angle of depression. So right here, this guy is the angle of depression. It's the angle measured below the horizontal. Whenever we see this arc, that means that's the angle that we're talking about. And the angle is measured from the horizontal down to the next line. That's the angle of depression. Okay? It is also called the angle of declination. So in your also called box, it's the angle of declination. Do you see the base word in declination? Decline. It's going down. Good job. So for instance, if we were at the top of a building and we wanted to note the angle of declination or the angle of depression between the top of the building and the bottom of the next building, maybe we're looking across the street to the next apartment building, we're looking at the main entrance and we want to see the angle of depression, that would be the angle straight, the line straight across is called the horizontal. Then you have your line of sight going to the door, and the difference between those two lines, the angle in between there, is called the angle of depression. So when you're looking down from somewhere, it's an angle of depression. Good. The next term that we need, any guesses what it's going to be? It's not the angle of depression, but the angle of elevation. The angle of elevation, also called the angle of, any guesses? Declination, decline, incline, inclination. Good. Ascension, I like that. Angle of inclination. Do you already know the definition?
Angle measured above the horizontal.
Nice. This is the angle measured above the horizontal. We're thinking today. I mean, not to say you don't think other days, but the angle measured above the horizontal, and you can probably think of the diagram for it, but I'm going to go ahead and help you draw the diagram. So we've got what kind of looks like a building over here, and this time, rather than us being at the top of the building looking down, we're going to be down here. Draw our horizontal, and we're going to be looking up at the top of the building. And we're going to be measuring our angle from the horizontal up. This is our angle of elevation. Angle of elevation. Excellent. I think we're ready to tackle a problem. Can you think of any other time angle of elevation would come into play?
If you're shooting.
Maybe you're shooting. Very good. So here you are standing with your shotgun. Skeet gets shot out of the skeet shooter. Is that what it's called? The thrower.
Yeah.
Sling thrower or thrower. You look up, right there, from the horizontal up to your line of sight. That's the angle of elevation.
Wow.
Perfect.
Good.
Except that you miss.
No, you never miss. So if you do it right, if you calculate your angles correctly and the speed and trajectory of the disc. Let's tackle example 1. You can see the diagram there. It has 2 triangles that are going to work together, and both of those triangles have a right angle in them. So we already know that some of our skills are going to apply. Maybe the primary trigonometric ratios will apply. Maybe Pythagorean theorem will apply. Let's go ahead and read it and see if we can figure out what we need to do. Kim and Yuri live in apartment buildings that are 30 meters apart. Can you see that noted in the diagram? The angle of depression from Kim's balcony to where Yuri's building meets the ground is 40 degrees. So we have Kim's balcony marked there with a K, and she's looking down at Yuri's building, the front door, and she's got an angle of depression of 40 degrees. The angle of elevation from Kim's balcony to Yuri's balcony is 20 degrees. And our goal is to find out A, how high is Kim's balcony above the ground, and B, how high is Yuri's balcony above the ground. Any ideas on first steps? What are we trying to find here, really, if we had that diagram?
Angle.
Well, we already have angles.
The angle from Kim's balcony to Yuri's building.
No. To Yuri's balcony. No.
Yes. The building is 30 meters.
The line from
Kim's
Kim's balcony to Yuri's
What he's saying is it's still 30 meters no matter how high you go up in the building. It's still 30 meters.
the horizontal.
Yeah.
If we're looking closely at this diagram, we can see that we have a bit of a triangle right here, but we only have this information for it, 30 meters of a length. And then we have another triangle here, And for that we only have a 40-degree angle. And we have an upper triangle here. For that we only have an angle of 20 degrees given. So we don't have enough information as it stands, but if we know that these buildings go straight up, those are parallel lines. And if the buildings are 30 meters apart from each other at the bottom, then in the middle here, across our horizontal, they're also going to be 30 meters apart. So we have the length of this side as 30 meters. Well, now we can use that information and apply it to finding the height of Yuri's balcony. But first we're going to apply it to find the height of Kim's balcony, because now we have enough information to find this side, which we'll call h sub k, which means the height of Kim's balcony, because the height of this right here, Kim's balcony, will be the same as the height right there. So let's use that information. We've got an angle of 40 degrees. We're given one side length here, that's the adjacent side, and we're looking for the opposite side. So we've got an angle, the adjacent side, and the opposite side. So the trigonometric ratio that we're dealing with here to find h of k is the tangent ratio. So we're going to take the tan of 40 degrees. We know that's is equal to opposite over adjacent. So we know that the tan of 40 degrees is equal to the height of Kim's balcony over 30. And to get the height of Kim's balcony by itself, all I have to do here is multiply both sides by 30. Over here we'll have 30 divided by 30, that crosses out, that's 1. And if we flip it around here, we get the height of Kim's balcony is 30 times the tangent of 40 degrees. And we use our calculator there. The height of Kim's balcony is approximately 25.17 meters. So to answer question A, the height of Kim's balcony, is about 25 meters. Kim's balcony is about 25 meters off the ground. Well, that's great. Now I have more information for my diagram. I have HK here, maybe I'll just write HK, equals 25 meters. Now to find the height of Yuri's balcony, all I have to do is take this height of 25 meters and add it to this missing height. So there's my next step right there. I need to find the height of that section right there. Maybe just for simplicity, we'll call it H2. So we've already got HK, which is going to be right here. In order to find Yuri's height, we're going to add HK to H2. We're just going to add these two heights. So again, we can use our top triangle there, our upper triangle. We have an angle of 20 degrees. We have a side length of 30 meters. This is the adjacent side. And we're looking for the opposite side. So once again, we're going to use the tangent ratio. And when we know that the tangent of angle 20 is going to be opposite over adjacent, it's going to be h2 over 30. If we multiply both sides by 30, cancel out on the h2 side, leaving us with just h2, and that's equal to 30 times the tangent of 20. Now in most scientific calculators, you can just punch in 30 times tan 20, or even just 30 tan 20, and you'll come out with an approximate height of 10.92 meters. Now to answer question B, using our work here, really this should be up here. This is just the final statement that we're going to add. Since Yuri's balcony is about 11 meters taller than Kim's balcony, since Yuri's balcony is about 11 meters taller than Kim's balcony, we know Yuri's balcony is about 25 plus 11 equals 36 meters above ground. And that's example number 1. We first calculated, we used the information that we had to calculate the height of Kim's balcony. Then we found this missing height. We added them together to get the height of Yuri's balcony. And we finished it off with a statement. Okay, in example 2, we are given a 3-dimensional picture. So you can see there's a river and a cliff. And the river is below the cliff. We have triangle FXC. That's the vertical triangle. And then we have a horizontal triangle XYC. So while you're looking at the diagram, I'll read the problem and see if we can understand this. A theodolite is an instrument used by a surveyor to measure horizontal and vertical angles. Measurements are taken in order to find the height of a cliff on the other side of a river, as shown. Find the height of the cliff to the nearest meter. So this is a little more complicated than our similar triangles height of the tree problem. And we have to keep organized in our head that even though the diagram, it doesn't look like 2 right angle triangles, because one is vertical and one is horizontal, we're told that XCY is a right angle triangle. Can you see how we're told that?
Is it like we're looking down and across?
You're kind of like
No,
looking
they're
across.
Yeah.
You're like on top of a higher cliff and you're looking down and across it.
Yeah, sounds good. So find the height of the cliff to the nearest meter. What do you think our strategy would be? We need to find the height of the cliff, which is represented by CF. Do we have enough information in that triangle to find the length of CF?
Nope.
No, we don't. But we do have another triangle. And are there any side lengths that are shared by the 2 triangles? What's the side length called that's shared? CX is shared, right? CX is in both triangles. So from the horizontal triangle, the flat river triangle, do we have enough information there to find the length of CX? And then if we had CX, would we have enough information in the vertical triangle to find CF? Excellent. So we're going to just say what we're going to do first. Okay, we're going to use, this is example 2, we're going to use triangle CYX, that's the horizontal triangle, to find the width of the river. And that's represented as CX. CX is the width of the river. That's going to be step 1. Step 2, use triangle CXF to find the height of the cliff, which is represented CF. Well, in order to help me with this horizontal triangle, the diagram, it's good enough. I could get it from there, but I might want to just redraw that triangle so that I can get the top view. So I want the top view of CYX. If I was standing on top of the cliff and I could see the triangle CYX, it's not great. It would look more like this. And we're given the measure of angle Y, 52 degrees. We're given that X is a right angle, and we're also given the length of XY, 75 meters. which primary trigonometric ratio are we going to use in order to find the length CX? We've got an angle here, and we've got an adjacent side, and we're looking for the opposite side. We're using tan again. Tan seems to be a fan favorite. Tangent of 52 is equal to opposite over adjacent. So we're CX over 75. How do I solve for CX? Multiply both sides by 75. CX equals 75 times the tangent of 52. In the calculator, you will get 95.996. So I'm going to go ahead and round that to 96 meters. And in your picture on your worksheet, you can add that to the diagram. CX is 96 meters long. Since it's shared by both triangles, we can use it to find the height of the cliff. So I'm going to give the side view of our vertical triangle, the side view of triangle CXF, and it will look something like this. CFX, where C is given as a right angle. We have the angle X given as 61 degrees. That's he's using his tool to look at the top of the cliff. So he's actually finding the angle of elevation there, right? The angle of elevation is 61 degrees. And we've just found CX. CX has a length of 96 meters. Now our goal is to find the height of the cliff, CF. So I've got an angle, and I have adjacent information and opposite information. What ratio are we using? Yeah, we're using tan again. Tangent of 61 is equal to opposite over adjacent. We don't know the measure of the opposite side. It's just CF, it's the height of the cliff. And the adjacent side is 96 meters. How do I solve for the height of the cliff? Multiply both sides by 96. I got to get CF equals 96 times the tan of 61 degrees. And in our calculator, that's going to be 173.2 meters. Are we done? Did we find the height of the cliff? Still need to put a statement. Yep, but we have finished all of the math necessary, right? So our final statement, the height of the cliff is about 173 meters. On the very bottom of your worksheet, you have a fill in the blanks for the key concepts of this lesson. And if you think you know one of those blanks, you can call them out. Angles of elevation are measured. Angles of elevation are measured above the horizontal. Above the horizontal. Well, that'll make the next one easier. Angles of depression are measured below the horizontal. So for instance, if you had a problem and there's an airplane driving in the sky, there's my airplane.
Wow, that's a small airplane.
Okay, and there's a watchtower.
Let's take a microphone.
And the watchtower is looking at the airplane, and you have to find out the height difference between the watchtower and the airplane.
You're going to use a triangle.
You need to think, even though there's not a horizontal given, you need to think about a horizontal. So from the watchtower to the airplane, here's the horizontal, making this the angle of elevation. If you're looking from the airplane down, you'll need to think, okay, this is my horizontal, which makes this my angle of depression. Okay? So if there's no horizontal given, you know what it means, you know how to draw them, you know how to form triangles. Okay? Both of these just form triangles. Once we've determined our angle of depression or angle of elevation, we can then use the primary trigonometric ratios. The primary trigonometric ratios can be applied to solve
Angles of depression and elevation.
Architecture,
Angles
engineering,
and size.
Three-dimensional problems.
Angles and
Medicine.
size.
yeah, two-dimensional,
and criminal detection, actually.
Angles and size.
two-dimensional, and three-dimensional
Further back.
problems involving, what do all the
Triangles.
problems, yeah, what kind of
Right
triangles?
angle triangles.
Right triangles. Right triangles. And some complex problems involve working with more than one,
Triangle.
what kind of triangle?
Right.
More than one right triangle. Next unit we learn how to solve triangles without right angles. Okay, ladies and gentlemen, your homework is there for you on the bottom of your worksheet. If you haven't corrected your worksheet or you have an old one, then the homework should say this: 348, number 1 through 7, and page 355, number 1 through 14. Enjoy.